This is section 14.5 on the chain rule, and it's just an extension of the chain rule that we had in Calc 1 and perhaps some of Calc 2. So let me show you what you need to know for that. Okay, so on page 937, you might recall the chain rule from earlier. One of the variations is equation 1 dy dt can be thought of as dy dx, dx dt. Y is a function of x, x is a function of t. It kind of looks like you can cancel out the dx's like this, right? It's rate of change of y with respect to x times rate of change of x with respect to t. Okay, so in multivariable, it's pretty much the same thing. Okay. So on page 938, you can put this on your cheat sheet if you wish. Okay, so this is all you need. These are the hypotheses that need to be satisfied for pretty much every function that we deal with. That's going to be true. Z is f of x, y, it's differentiable. And x and y are both differentiable. So dz dt, partial of f with respect to x times dx dt, plus partial of f with respect to y, dy dt. Okay, you could also have this version here. You can put this on your cheat sheet also. And what's the difference between this and the previous one? There really isn't any. If you look over here, they have f here. And over here you have z, but it's really the same thing. Z is the function. So dz dt is partial of z with respect to x times dx dt, plus partial of z with respect to y, dy dt. And again, it kind of looks like you can cancel the dx's and the dy so that you just have the rate of change of z with respect to t. All right, then more complicated versions of the chain rule on page 939, box 3. Suppose z is a function of x and y, but x and y are both functions of, let's say, s and t. Then it gets more complicated. So you can see the partial of z with respect to s, partial of z with respect to x times partial of x with respect to s, plus partial of z with respect to y times partial of y with respect to s. These can get really long, admittedly, but it's not really hard. You're just taking a whole bunch of derivatives and just make sure that you line everything up the right way. Again, you don't have to memorize this, but if you were to memorize it, it kind of looks like you can cancel the partial of x with respect to x and the partial of with respect to y, and then you just have the rate of change of z with respect to s. Similarly, partial of z with respect to t, partial of z with respect to x, partial of x with respect to t, it kind of looks like the partial with respect to x cancels out, plus partial of z with respect to y, partial of y with respect to t. Okay. Now, it can get much higher. This is the general version on page 940. This is if you have 3, 4, 5 variables. I wouldn't advise you to write all that out. Okay. I think we do have some problem which is longer. I don't think we do anything this big. Okay, but what is this? It's basically if you have all the different variables, you just line them up, you chain them together. Like you can see over here, partial of u with respect to x1 times partial of x1 with respect to t1, and these kind of cancel out, and you just keep doing that all the way down the line for all the variables. Okay, the examples that I'll show you hopefully will make this clear. Okay, and then implicit differentiation on page 942. I want to put this down. So the implicit differentiation, remember we did that in Calc 1. We have capital F of xy equals 0. Okay, dy dx can be written, so they've formed a chain rule here, but dy dx is negative fx over fy. Okay, I think it's easy if you just ignore this middle one and say dy dx is the opposite of fx over fy. Okay, it was the chain rule that we had, except they cleaned it up a little bit. Harder version is on page 943, box 7. Okay. So partial of z with respect to x is negative fx over fz. Partial of z with respect to y is negative fy over fz. Okay, so that's if you have a function of 3 variables involved. In fact, we should put this right up here. So capital F of x, y, z equals 0. Put this on your cheat sheet, actually. If it starts off with capital F of X, Y, Z equals 0, then you use these things. All right, so here we go. 14.5 homework, page 943. Get this thing focused here. And that. Next page. Here. Over here. Here. Oops. And I think that was pretty much about it. And double check what was the highest problem we had to go up to. Yeah, 35. Yeah, so you've got it all there. Okay. Okay, number 1, z equals xy cubed minus x squared y. X is given to be t squared plus 1. Y is t squared minus 1. So by formula, dz dt is the partial of z with respect to x times dx dt plus the partial of z with respect to y dy dt. And they're all fairly straightforward. Just be careful about for your partial derivatives. So when you differentiate with respect to x, that means you treat y as a constant. So partial of z with respect to x, y cubed minus 2xy times dx dt is 2t plus partial of z with respect to y, 3xy squared minus x squared times the partial of y with respect to t, 2t. That's all there is to it. Okay, 5 is a little longer just because there's 3 variables, x, y, and z. So w equals x e to the y, z to the negative 1. X is given to be t squared, y is given to be 1 minus t, and z is 1 plus 2t. So they want dw dt, so it's the partial of w with respect to x times dx dt. Notice again, it kind of looks like the dx or partial with respect to x cancels out. And partial of w with respect to y, dy dt, plus partial of w with respect to z, dz dt. So you're doing 6 derivatives. Okay, so differentiate with respect to x. Well, you just drop the x, e to the y over z. Then dx dt is 2t. Partial of w with respect to y. So x e to the y over z times the derivative of y z to the negative 1 with respect to y. That's just going to be 1 over z. So I get the original x e to the y over z divided by z times dy dt, which is negative 1. And then partial of w with respect to z. So that's x e to the y over z times derivative of this is negative y z to the negative 2, which simplifies to negative xy over z squared e to the y over z times dz dt, which is 2. So these aren't really hard, I think, they're just long. All right, z is a function of 2 variables, but x and y are both functions of 2 variables. So I have to do the longer form of the chain rule. So partial of z with respect to s and partial of z with respect to t. So partial of z with respect to x, sorry, it's hard to even say this, partial of x with respect to s plus partial of z with respect to y, partial of y with respect to s. All right, so let's see, partial of z with respect to x. So it's 1 over times the derivative of this with respect to x, which is 3. Then partial of x with respect to s is just sine t. Then partial of z with respect to y is 1 over 3x plus 2y times 2. And then partial of y with respect to s is negative t sine s. All right, so just put them together. 3 sine t minus 2t sine s over 3x plus 2y. Okay, then the partial of z with respect to t, well, it's the same thing except put a t there and a t there. I've already done this, so that's going to match that, just copy it. That's going to match that, just copy it. Okay, so it's still going to be 1 over 3x plus 2y times 3, and that's going to be 1 over 3x plus 2y times 2. Only difference is now when I get to here, I take the partial of x with respect to t. That's going to be s cosine t. And you want the partial of y with respect to t, that's just going to be cosine s. So you end up with that. All right, so let's see. 21. Z is this. X is that. Y is that. S is 4. T is 2. U is 1. So we're just plugging in. So at the appropriate time, I'll plug in stuff. Okay, and first figure out X. X is S plus 2T minus U, which is 4 plus 2 times 2 is 4 minus 1 is 7. Y is STU squared, so that's 4 times 2 times 1 squared is 8. Okay, so I figure out the expression, and then I'm just going to plug in. So partial of Z with respect to S is partial of Z with respect to X times partial of X with respect to S plus partial of Z with respect to Y times partial of Y with respect to S. Okay, so partial of Z with respect to X is 4x cubed plus 2xy times partial of X with respect to S, 1, plus partial of Z with respect to Y. There is no Y, so that's nothing. It's x squared. Partial of Y with respect to S, TU squared. Okay, now you just plug everything in. Plug in X, Y, S, and T as necessary. So 4 times 7 cubed, X is 7, plus 2 times X times Y, 7 times 8, plus X squared, so 7 squared. T is 2 times U, 1 squared, comes out to be 1582. And do the same thing for partial of Z with respect to T and partial of Z with respect to U. Okay, so I've got it all down here. This stays the same. We already did that, so I'll copy that and copy that. And likewise, we already did partial of Z with respect to Y, so we copy that, copy that. So the only thing new is partial of X with respect to T, 2, and partial of Y with respect to T, SU squared. Okay, then plug all that stuff in, 3164. And then over here, again, that's the same. That's the same. Partial of X with respect to U, -1. That's the same as before. And then, let's see, partial of Y with respect to U, 2 STU. And then just plug it all in, -700. Okay, 25. N is equal to that, which might be more useful to think of it as such. P is U plus VW, Q is V plus UW, R is W plus UV. They give me U, V, and W. Let's figure out the P and the Q. So P is U plus V times W, 2 plus 3 times 4, 14. Q is V, 3 plus UW, 2 times 4 is 8, 11. Okay, and R is, let's see, 4 plus 6, which is 10. Okay, partial of N with respect to U is partial of N with respect to P times the partial of P with respect to U, plus partial of N with respect to Q times partial of Q with respect to U, plus partial of N with respect to R, partial of R with respect to U. So it's just a lot of derivatives. All right, so partial of N with respect to P is P plus R squared in the denominator, P plus R minus P plus Q, which comes out to be R minus Q. Okay, plug everything in, -1 over 576. Partial of N with respect to Q, well, it's just 1 over P plus R, 1 over 24. Partial of N with respect to R, so P plus Q, -1, P plus R to the -2. Clean it up, negative P plus Q over P plus R squared. Plug everything in, negative 25 over 24 squared, negative 25 over 576. And then these partials, partial of P with respect to U, 1. Partial of Q with respect to U, W, which is 4. Partial of R with respect to U is V, which is 3. So partial of N with respect to U, plug that in. So it's just a replacement now. So negative 1 over 576 times 1, plus 1 over 24 times 4, plus negative 225 over 576 times 3, 5 over 144. Similarly, for all this stuff, I need to see, we already got that, we already got that, we already got that. So just copy those. So negative 1, 576, 1 over 24, negative 25 over 576. And then partial of P with respect to V, W, which happens to be 4. Partial of Q with respect to V is 1. Partial of R with respect to V is U, and that comes out to be 2. So 4, 1, 2, grind it out, negative 5 over 96. Then partial of N with respect to W, that stays the same, negative 1 over 576, we saw that earlier. Partial of N with respect to Q is the same, 1 over 24. Partial of N with respect to R is the same, negative 25 over 576. Then you need partial of P with respect to W is V, which is 3. Partial of Q with respect to W is U, that's 2. Partial of R with respect to W is 1. Plug in here, here, and here, 5 over 144. Okay. All right, then the implicit differentiation. Y cosine x equals x squared plus y squared, find dy dx. So by rule, we have to put everything on one side equal to 0. So either subtract that or that goes 0. You get the same answer either way. So I decided to subtract y cosine x. So capital F of xy is x squared plus y squared minus y cosine x. Set that equal to 0. So dy dx by formula is negative fx over fy, which is the opposite of partial with respect to x is 2x plus nothing plus y sine x divided by fy, nothing, 2y minus cosine x. 31, x squared plus 2y squared plus 3z squared equals 1. Move the 1 over, minus 1 equals 0. So partial of z with respect to x is negative fx over fz. So negative partial with respect to x is 2x. Partial with respect to z is 6z. Negative x over 3z. Very easy. Partial of z with respect to y is negative fy over fz. So opposite of fy is 4y. We already did that, 6z. Negative 2y over 3z. Okay, then 35, they tell me x is that, y is that, t is 3. So if t is 3, I plug in, that gives me 2. And that gives me 2 plus 1, which is 3. Okay, so t sub x at 2, 3 is 4. That's given. And t sub y at 2, 3 is 3, that's given. So partial of t with respect to t, capital T, temperature, little t, time, is partial of capital T with respect to x, dx dt, plus partial of capital T with respect to y, dy dt. So what is dx dt? This is 1 plus t to the half, so the derivative is 1/2, 1 plus t to the negative 1/2, or 1 over 2 radical 1 plus t. Plug in 3, I get 1 over 2 times radical 4, 1 over 2 times 2, which is 1/4. And dy dt is 1/3. All right, so I just plug everything in. So partial of big T with respect to little t is, that came out to be 4, and that came out to be 1/4. So 4 times 1/4. And this came out to be 3 times 1/3. So it's 1 plus 1, or 2. Units are 2 degrees Celsius per second. All right. So that is section 14.5.